So we're solving rational equations. What makes rational equations, difficult to solve for is the variables usually in the denominator. Okay, a very basic rational equation could look something like this. That's a rational equation. Your variables in the denominator. How would you guys go about solving that for x?
Multiply 5 both sides.
Why? If you multiply both sides by 5. Okay, let me address what you said. All right, first. Multiply by 5 would give me 25 over x equals 100. You're still in the same boat. The x is still in the denominator. Now you've changed it to multiply both sides by x, because what does that do for you? Gets rid of the x. You don't have a fraction on this side anymore. Excuse me, gets rid of the x on this side, cancels that x out, okay? And you don't have a fraction anymore. So I multiply both sides by x, and I get 5 equals 20x, right?
Yeah.
Then obviously divide both sides by 20 and you get 1/4. X equals 1/4. Okay? Going into this problem, there is one number that you know is definitely not an answer. 0. Because? Yeah, you can't divide by 0. I can tell you right now, this answer cannot be 0. Okay? Then we solved it. We got 1/4, which is not 0. So that must be the right answer, but I would check it. 5 divided by 1/4. It is 20. It works. So there's your solution. Okay? So that's a very, very, very basic rational equation. Okay? If you had to explain to somebody how to solve that problem, okay, obviously you'd say, well, multiply by x first. But why? Why would we multiply by x first? Yeah, to get x out of the denominator. After we multiply both sides by x, we didn't even have a denominator anymore, right? Mm-hmm. So multiplying both sides by the denominator gets rid of the rational part of the equation, and it just becomes a nice linear equation. Okay? So let's go something like this. 7 over x plus 2 equals 12. What answer can x not be? Negative 2, because that would give you a 0 in your denominator. So if, when we solve this thing, we get x equals negative 2, you'd actually say there are no solutions because x cannot equal negative 2. Okay? What do you think we need to do to both sides? Multiply both sides by x plus 2. When I multiply both sides by x plus 2, what happens to the left side? It's just 7. Yeah, it cancels out, right? The x plus 2 would cancel that x plus 2. You'd have 7 equals what? 12x plus 24. Subtract 24 from both sides. You get negative 17 equals 12x. Divide both sides by 12, and I don't feel like getting out a calculator, so a nice reduced improper fraction is perfectly fine with me. Negative 17/12 would be my value for x. Want to make sure it works. Take negative 17/12, plug it back in for x. Make sure it satisfies the equation. Okay? Questions on that? Alright, pretty easy. Again, what did we do to both sides right away? We multiplied by the denominator, right? Okay, simple enough. Let's do this. 4 over x plus 3 over x minus 2 equals 10 over, now we'll keep it simple right now, x. Our thought process on the last few has been to do what? First step,
Multiply by the denominator.
multiply by the denominator. Okay? What makes this one a little more difficult?
3 x's.
There's more than one denominator, right? Okay. And all the denominators are not the same. Correct? Okay. You can still figure out what to multiply everything by that would get rid of the ratio part. Okay? And that would be your least common denominator. Okay? If you multiply everything by the least common denominator, you will not have a rational function anymore, or a rational equation, excuse me, anymore. What would our least common denominator be here? Okay, let me just go throw out an example. Let's say x was 7, for instance. Okay? If this was 7, then this denominator would be what? 5. And that denominator would be 7. So if this was 7, this was 5, this was 7, what would be your least common denominator? 35? How'd you get that? 7 times 5, right? Okay, so what's going to be our least common denominator? X times x minus 2, whatever x times x minus 2 is. Just like you took 7 times 5, okay, to get the least common denominator. I'm going to say our least common denominator here, our least common denominator is whatever x times, whatever x times x minus 2 is. Okay? So what I would do is I would multiply every fraction times x, x minus 2, times x, x minus 2, times x, x minus 2. I'm going to just multiply both sides of the equal sign, which, even though there's more than one term on this side of the equal sign, if I would multiply that entire side by the least common denominator, I'd have to distribute it, so each term would be multiplied by x, x minus 2, so that's why I just write it times x, x minus 2. On this first fraction that I have, 4 over x times x, x minus 2, what's going to happen to your x's? Cancel. You're left with 4 times x minus 2, which is really what? 4x minus 8. Tell me to slow down if I need to. On the second fraction, when I take 3 over x minus 2 times x, x minus 2, what happens? X minus 2's cancel, and all you're left with is 3x, so plus 3x. Equals, what am I going to have on the right side? 10x minus 20, because the x's would cancel right here. I'd be left with 10 times x minus 2, which is 10x minus 20. I've multiplied both sides of the equal sign by the same thing, and now all of a sudden I have a nice linear equation. Okay? So combine like terms. 7x minus 8 equals 10x minus 20. I'm going to move all my x's to the right side. So I'm going to subtract 7x from both sides. That'll give me 3x here. I'm going to add 20 to both sides. That'll give me 12 here. And x will equal 4 when it's all said and done. And I'm pretty certain that answer will work. Okay? The only answers that would not have worked, what values of x definitely could not have been solutions? 2 and 0. Okay? 4 probably works. I'll double check here. 4 divided by 4 is 1. 4 minus 2 is 2. 3 over 2 is 1.5. So I have 1 plus 1.5, which makes 2.5, right? And then here I have 10 over 4. Is that also 2.5? Yes, it is. So it satisfies the equation. X equals 4. Okay? Process is really easy. Figure out your least common denominator. Multiply every term by the least common denominator. And then you'll have a nice equation that's going to be fairly simple to solve. It's going to be a linear equation, might be a quadratic equation at most. Okay? It should be pretty easy. Right. We'll do one more to try and make it a little more difficult here. Let me find the top. Alright, this will be nice and challenging. Okay? Alright. If I would see this equation, the first thing I would actually kind of do is I would look at my denominators and ask if any of them are factorable. Okay? Which these are factorable. I could take an x out and then I'd have an x plus 1 left over in the parentheses. So really, x squared plus x is the same thing as x times x plus 1, right? So this one would also be x times x plus 1, right there. So this fraction has a denominator of x times x plus 1. This fraction has a denominator of x times x plus 1. This fraction has a denominator of simply just x plus 1. What's my least common denominator? X times x plus 1, right? So this fraction already has the least common denominator in it, so does this one. All this fraction needs is to be multiplied by x if you wanted to give them all the same, common denominator. Alright, so because my least common denominator is x plus 1, I'm just going to go ahead and multiply everything by x plus 1, x plus 1, x plus 1. What happens to the first fraction? Everything, the denominator is canceled, right? Because this will cancel the denominator and all you're left with is x plus 5. How about the second fraction? Yep, cancels the denominator again, all you're left with is 1. How about the last one?
X plus 1 will cancel.
X plus 1's cancel, so all that's left is x minus 6 times x, which would be what?
X squared minus 6.
X squared minus 6x. But that is being subtracted, right?
Yeah.
So you have to subtract x squared minus 6x. So that means I'll have x plus 5 equals 1 minus x squared plus 6x. Because you're subtracting that quantity, you're subtracting that product that you had over here. When you took x times x minus 6, you got x squared minus 6x, but that was being subtracted, so you're subtracting that quantity, which resulted in x plus 6x back there. Now this is a quadratic equation. How do you solve quadratics? Hopefully you can factor it. Okay, I hope you can factor it, otherwise you got to use quadratic formula. If you want to factor it, you always want to set it equal to 0 first, and you always want to try and have your x squared term be positive. So I'm going to move everything over to the left side of the equal sign. I had to add x squared to both sides, so that would give me an x squared on this side. I'd have to subtract 6x from both sides, so that would give me a negative 5x on the left side. Because I have x and I'd be subtracting 6x, so negative 5x. And I also would have had to subtract that 1 from both sides, which would give me 4. How are we doing? Okay? Is that factorable? What are my two factors? X minus 4 and x minus 1. So what are my two solutions? X equals 4 and x equals 1.
I'm still confused. How'd you get to the negative 6x to the positive 6x?
I'm subtracting it. I'm subtracting a negative 6x.
Oh, okay, so that'll change.
So I'm subtracting an x squared and I'm subtracting a negative 6x.
Oh, okay, so that's why that.
Distributing the
Why
minus
the
sign.
parentheses.
Yeah,
Okay.
yep. Okay? I would check them. Okay? I would always check my answers, make sure they both work. Okay, if we try a 4, 4 squared plus 4 gives me 20 there. 4 plus 5 is 9, so I have 9 over 20 on this side. Hopefully I get 9 over 20 on the other side. Okay? This is 4 squared plus 4 is again 20, so I have 1/20th. 4 minus 6 is negative 2. 4 plus 1 is 5, so I have negative 2/5, but I'd be subtracting a negative 2/5 would be like adding 2/5. So 1/20th plus 2/5. 1/20th plus 8/20 is 9/20, which is what we had on the other side. So 4 works. And you guys are probably going to use your calculator for a lot of that stuff. Alright, I'm just trying to do it quickly up here. Then I plug in a 1, see if that works. 1 plus 5 is 6. 1 squared plus 1 is 2. 6 over 2 is 3, so I got a 3 on that side of the equal sign. 1 plus 1 is 2, that'd be 1/2. 1 minus 6 is negative 5 over 2, so plus 5 over 2, so 1/2. Plus 5 over 2 is 6 over 2, which is 3. That's what I have on the other side. So both answers end up being solutions. Okay? I would always check my answers when I'm done solving. Okay? You usually should be able to tell though if an answer is not going to be a solution by simply looking at the denominators. What values of x are definitely not possible for solutions? -1 and 0. Okay, -1 and 0 are definitely not going to be solutions for x, because if you try to plug in a -1 or you try to plug in a 0, you're going to get an undefined. You're going to get an error because you can't divide something by 0. Okay? So, rational functions, while they may look complicated, takes one step and you have a nice linear or quadratic equation to solve. What is that one step?
Multiply by the least common denominator.
Multiply everything by the least common denominator and you'll get rid of the rational part.
How is x squared plus x, how is that the least common denominator?
So, when I factored x squared plus x, it was x times x plus 1.
Okay.
Okay? So I don't know what x times x plus 1 is, but whatever that product is, that is the denominator of this fraction.
Okay.
Okay? It was also the denominator of this fraction. This fraction just had x plus 1. What would you need? Okay, so let's say it's 5 times 6. Okay? So this denominator is 5 times 6, this denominator is 5 times 6, this denominator right now is just 6. What does it need to be multiplied by?
That 5.
The 5, the x.
Okay.
So if you had to make all the denominators the same, wouldn't this be your least common denominator? X times x plus 1?
Okay. Because when I look at, well, now it makes more sense that, like, saying that the x plus 1 is already in each one. Because when I see that, I think, oh, that doesn't have an x, so that's, like, the least common one, because it, like, doesn't have an x. That's how I think.
You gotta think of it as, if I were to make all the denominators the same, what would be the easiest way to do it?
Okay.
Okay? You know, like if I have the fraction 3/4 plus 7/8. Well, sure, you could multiply 4 times 8 and get 32 and make both fractions have a denominator of 32. It wouldn't be a lot easier just to make this one have a denominator of 8 and call it good? Okay, because 4 goes into 8, right? Well, this goes into this.
Okay.
It's similar to that. If you really wanted to, it would become kind of an ugly polynomial. But if you wanted to take this times this, so take x squared plus x times x plus 1 and FOIL that out or see what that is, I mean, you could get the right answer, it would just become a really complicated problem. Okay? So just try to identify what the least common denominator is, or in other words, what both denominators can easily go into, and then whatever that is, just multiply everything by that and don't cancel stuff.
Okay.
Okay? Alright, that's it. Solving rational equations, pretty simple.